like if we have range, you have things like measurements. We can say, what's the set of numeric values and what unit are you working on? So with weight, you might say it's between 0 and 30. So other things might say it's between 0 and 10 and 90 and 100. So we made it so you could have a set of these legal values and put whether it's less than or equal to or greater than or equal to. So really we could define what's the possible collection of values that you can take here. And so what that did was that extended our framework to saying now our types of observations for our people could have different types of measurements or traits. We can compose them together. And by the way, here's the legal set of values. The null validator is in case, for example, you might have an observation that any value is legal. Like the doctor's observing something about you and he's writing a textual description of what he observed. So we use the null object pattern written up by Bobby Wolf design pattern, and it really describes, it's a way of handling when you don't want to do anything. So it still acts as the same interface as these others. It's just a strategy saying everything's always valid. So when we extend our observations, we can do something like that. And we can start asking a question I could ask, is everything an observation? For example, you're observing me right now. I'm observing you observing me, right? And so I could say even people are observations. And you could push the analogy too far. And this is the danger of people writing these types of systems, is they try to make things go too far. And that's where the complexity that was brought up before happens, is as computer scientists, we learn a new abstraction, and all of a sudden we want to use it for everything. This is cool. Let me test the limits of it. And that's where problems happen. And also, too, the model is missing something. This model is still missing something very important. When I have a composite observation, how do I know how to build it up? Remember when I had cholesterol? How did I know that cholesterol had two subcomponents? Well, maybe I stored in XML as sub things and my builder knows how to do that, how to take it. But the model itself can also represent this and give us more business rules about this. And also, we have traits and discrete validators. How do we know the relationship between them? This is highly coupled. Traits can only have a discrete validator. Measurements can only have a ranged validator, and they can all have null validators, I guess. But you can't put a ranged validator on a trait. It's a discrete set of values. It's not a numeric value, quantity. So how do we deal with that? So, once again, we extended our design. And here, the current design, this kind of shows, what do you see here is a dual hierarchy. But almost, this doesn't change. This is not an evolving dual hierarchy. This is like our class structure, saying for our types of observations, here's their structure. So if I need a new cholesterol, it'll be one of these types that can contain subtypes. And so you can say, give me a new cholesterol. It'll know how to build up an instance of one composed up. And notice here that primitive observations can really be two types. They're either ranged or discrete. How do we know what the types are? Well, depending upon what you've associated here, it'll define what the legal type of values are that you're going to hold here. So we really didn't have to have two subclasses in this. So, because that knowledge is associated on your primitive type by the type of validator that you had. And so this is used and in production in the Illinois Department of Public Health for a refugee tracking system, newborn screening that I talked about. And basically we use this model. And the power was, we released the system a couple years ago, and we put it out there, and we found out one of our business rules were wrong. We had temperature, the max temperature, the range on temperature, which was a ranged validator. Our test cases didn't catch it because we didn't have the right test case, was like 106 max. So we released it, and so normally what we'd had to do if we developed the other way, code up a new one, send out the CDs to everybody. This was not a web app because they didn't want a web app. You know, medical information on the web, they were all paranoid. You know, security is this cannot be shared information. Even though there's some secure ways you can maybe do it on the web, they didn't want to do that. They share data to the state through a telephone connection and replicate the data through that way. So we wrote a lot of infrastructure for that, you know, doing all kinds of cool things that this talk's not about. So I don't want to waste your time there. But really, the cool thing is after we released, since we had this architecture, and I found this out, we didn't have to release new software. I went in and I changed the range validator for temperature. I had a nice GUI for doing that. Hit a button, save. The next time they loaded up, they got the data. They got the new business rule, you know. And so if all of a sudden they had a new type of the medical arena, if they come up with a new type of observation or a new business rule for the observation, they learn something new, this system can adapt to that without writing any new code or changing things, because we've pushed out into the database all those changes for that system, so it can reflect those changes without coding within this restricted domain. If they came up with some kind of new thing that wasn't an observation, we'd have to go back to the drawing board and release a new system. But within this domain, which worked well for their system, this is an adaptive object model. We can define new types of observations, new type of people. That was basically our entities and properties. And the observations are like what Brian Foote and I call smart variables, because they had a lot of knowledge embedded with them about the types of properties, types of variables in your system. And so really when you look at it, this is the part that it's the operational level, what Martin Fowler would say is the operational level. This is the part, a running system that you're building new instances of these types of objects and persisting them for the types of observations and people in your system. The top part, that's the meta architecture. This is the knowledge level. This is known as the knowledge level. And it's the part that's describing, and you can change. It's like when you write new code, you're putting a certain amount of knowledge into your code when you're writing it. And so that's what's happening here at this level, right here. And so we can look at this for observations. Here's a more composed one. And here we have galactosemia, which is something that you check for on infants. And galactosemia is really composed of other observations which have a lower level galactosemia. This is a composite galactosemia. And UDT, which is a range validators. So it's a quantity type of object that we're capturing values for. And you could even, you put it all together. Maybe we're checking a gestational age, which is a discrete validator maybe. And then we also have galactosemia. So really, for infants, we have a collection of observations we have for these infants, which are types in our system that I showed you before. And here's the types of legal values. And we're able to associate the business rules about the values through the strategy objects. And so here, when you put it all together, this was our new types of people in the system, the party type. What I'm not showing you here is you had the accountability here as well. So we defined the legal relationships. I didn't want to clutter up the diagram anymore for simplistic. And here's the legal types of values that these types of infants or mothers or doctors were capturing about them. And when we're creating real values, the operational level, this is what our user interface is, or when we're typing in values, we create instances of and save. Okay?